Alright guys, I know that some of you guys may feel intimidated when you are given a mixed fraction and you must add it to another mixed fraction. I'm going to try to put this at ease for you, and hopefully this helps. I'm going to have two methods I'm going to show you. I'm going to use a t-chart as one method, and then converting my mixed fraction to an improper fraction, and then hopefully you can pick which method you like best, and it'll always work this way. All right, t-chart is just that. I'm going to create a t-chart that has my whole numbers and my fractional parts. There it is. In my first fraction, I have 2 and 2/3. Well, the 2 is my whole number, and my fractional part is 2/3. There it is. And then I put these into the chart, and 3 is my whole number, and then 1/4 is my part. Now I'm going to add both columns up. Well, this is fairly simple whole number, and 2 plus 3 is 5. Well, I know that. Well, this here, we must follow the rules for fractions. We can't add fractions just as 2/3 plus 1/4. And most kids want to just add 2 plus the 1, which gives us the 3, and then 3 plus the 4, which is 7, and then they get this answer, and then they want to put it here. Unfortunately, that does not work. So this is incorrect. So what I tell the kids is set it up horizontally, 2/3 plus 1/4. And there's a lot of different ways to do this, but the easiest way I tell the students is do the swing method, so it comes with the story. So I'm taking this 3, and I'm going to bring it into the swing set, times 3 is what I'm bringing over. So as the rule states, if you multiply the denominator by 3, I must do the same thing with my numerator. And then do the same thing. What am I going to bring from my right side, the 1/4 side, to my left? Well, I take my denominator and put it in the basket. And now I put times 4 times 4. When you do that, now you get 4 times the 2, which you get 8. 4 times the 3, which is 12, plus 1 times the 3, which is 3, 4 times the 3, which is 12. And what do you notice? Well, we have a common denominator. So therefore, I can add my numerators because my denominators are the same. So therefore, it becomes 8 plus the 3, which is 11, over 12. We never add the denominator. So I bring back on this side, 11 over 12 is my final answer using the t-chart method. I'm going to swing over to the other side. And now I'm going to use the improper fraction and convert this mixed fraction to an improper fraction first. It's just a little bit longer because you just have a little more calculation to do, but it'll still obtain the same answer as 5 and 11 12. So I take my denominator and make it a clock. There it is. Multiplication first, addition second. So therefore, 3, my dot tells me where I'm going to start from. 3 times 2, which is 6. 6 plus the 2, which is 8, over 3. That's what I started with. Plus, now I do the same thing over here through my clock, multiplication, addition. 4 times the 3 is 12. 12 plus the 1 is 13 over 4. And you can see that the fraction is getting a little larger, but we'll still get to the same answer. Again, I'm going to use my swing method just like I did over here and do the same thing. I'm going to take this 3, put it in a basket, and bring it over to the other side, times 3. So times 3 times 3. Bring the basket from my denominator from this fraction and put times 4 times 4 times 4. Now you can see that the fraction is getting a little larger, which is all right. Now when I multiply 4 times 3, I get 32 over 4 times 3 is 12. Plus, and the reason why I'm doing this is because my denominators are different. I have to get to the same denominator. 13 times 3 is 39 over 12, 4 times 3. And you may be asking, why is it that it really doesn't change the value? Well, it's a very good question, because if we multiply the denominator on this fraction, 13/4, by 3 as the denominator by 3 and the numerator by 3, well, when you really think about this, this here is saying 3 over 3 is really 1. So I'm really multiplying one group size, and when you multiply by 1, it doesn't change the value. It just makes it look different. It's like a convertible car. You can have the roof up or roof down. It's still the same car. It just looks different. That's all this is happening here. Now, because my denominators are the same, I can simply add, and when I add 32 plus the 39, I get 1 here, regroup, the 2 plus the 9 is 11, regroup the 1, so 3 plus 3 plus that 1 is 71, over 12. And now, how many groups of 12? Now you're just doing a little long division, saying that 12 divides into 71. Again, just remember that this fraction bar really means it's a division symbol. It's really a division symbol that you see here. Okay? So it's saying how many times can 12 go into 71? Or 71 divided by 12 is what it really means. Now, how many groups of 12s can go into 71? Well, I know that it's going to be 5, because 5 times 12 is 60. Because if I try to do with the 6, well, that's going to give me 72, and it's too big. And I can't go over my dividend. So subtract, and I get 11. My remainder will always be my numerator. So therefore, I have 11 over, what was my common denominator? 12. So that's the same thing as my divisor. So you can see that my final answer using this method is exactly the same as the T-chart. I just think that using the T-chart is a lot faster and smaller numbers are being used. Hopefully this helps you guys.